Welcome back to The Explainer. So today, we're doing something a little bit different. We're going to step into the shoes of a student detective. We're diving headfirst into the colorful, mysterious, and honestly, sometimes downright baffling world of chemistry. The goal? To look at your everyday kitchen or backyard garden and see a hidden science lab just absolutely packed with clues. Let's get right into it.
Picture this. You're walking around a school science fair, right? You walk up to a stall and a volunteer hands you this completely blank white sheet of paper. Then they spray a clear liquid over it. Instantly, like pure magic, bright letters appear spelling out, "Welcome to the wonderful world of science." I mean, how is that even possible? There's no ink, no hidden printer, just a blank page and a spray bottle. Keep that little mystery tucked away, because by the end of this explainer, you are going to crack this exact case.
But to solve puzzles like this one, we really need to channel our inner student detective. We're going to act as curious investigators, carefully documenting these bizarre chemical phenomena in our secret lab journal. Because as detectives, we can't just guess what a substance is. We need solid, undeniable proof to back up our claims.
And to get that proof, we need our primary investigative tool, acid-base indicators. Think of an indicator as, well, it's basically a chemical magnifying glass. It's a special substance, and these are often found right in nature, that physically changes its color, or even its smell, depending on whether you dunk it into an acidic solution or a basic solution.
So, let's build our very own natural indicator toolkit using the classroom scientific method. You don't need some multi-million-dollar fancy lab for this. Honestly, you just need a garden. Step 1. Take some beautiful red rose petals and immerse them in hot water. Step 2. Just wait patiently until the water draws out all those rich pigments and becomes deeply colored. And finally, Step 3. Filter out the petals. What you're left with is a pure liquid extract. It's genuinely an amazing transformation. We start with a simple, everyday red rose blooming in the dirt, and we end up with this really powerful filtered extract sitting in a test tube. We've literally just turned a garden flower into a piece of hard scientific evidence that's gonna help us unmask unknown chemicals. Okay, with our tools ready, it is time to interrogate our household suspects. We're going to categorize them using a famous laboratory indicator you've probably heard of, litmus paper. When we test lemon juice, it turns blue litmus paper red, which instantly identifies it as acidic. When we test a slippery soap solution, it turns red litmus paper blue, unmasking it as basic. But wait, look at this sugar solution. It doesn't change the color of either paper. This means it belongs to a third faction entirely, neutral substances. These guys are neither acidic nor basic.
Now, gathering this kind of evidence requires a pretty rigorous process. As student detectives, we use a white tile. We carefully lay out our litmus paper squares and then apply our suspects drop by drop using a dropper. It's a precise, highly systematic way to ensure our evidence is absolutely rock solid.
But hold on, what about that red rose extract we just brewed? How does that react to these factions? Well, if you drop our DIY rose extract into an acid, like say amla juice or vinegar, the extract turns a really deep, vibrant red. But if you drop it into a base, like lime water or a baking soda solution, it undergoes this incredible transformation and turns a striking green color. It's a brilliant visual clue, all thanks to those unique plant pigments.
All right, now that we've got our basic training out of the way, I'm going to present you with 3 high-order thinking situations. Think of these as our curious cases to keep you guessing. Here's case number 1. A student named Kirthi wrote a secret message to her grandmother for her birthday, but she used orange juice as ink. The paper looks totally blank, so as a detective, what indicator would you use to reveal this hidden message?
Moving on to case number 2. The beautiful hydrangea flower grows in the cooler climates of the Himalayan region, but it has a bizarre secret. If you plant it in acidic soil, it blooms with bright blue flowers. But if you plant it in basic soil, the exact same plant produces pink or red flowers. No way, right? Why does nature's own flora alter its colors just based on the dirt it sits in? Stick around, we'll get to the bottom of this shortly.
But hey, we aren't done building our toolkit just yet. We're going to create another essential piece of testing equipment straight from your kitchen spice rack. Just take a spoonful of turmeric, the famous golden spice, and mix it with water to make a paste. Dip some filter paper into it until it's completely bright yellow, let it dry out, and cut it into strips. Boom! You just created golden turmeric paper. Now, the crucial thing here is understanding the limitation of the tool we just made. If you drop a basic substance, like a soap solution, onto this yellow turmeric paper, it turns completely red. However, if you drop an acid or a neutral substance on it, absolutely nothing happens. It just stays yellow. So turmeric is a highly specialized detective. It's incredibly useful for sure, but it's really only useful for catching one specific type of suspect: bases.
Which perfectly brings us to curious case number 3. Let's say you accidentally drop some delicious, bright yellow curry on your crisp white shirt. You completely panic, grab a bar of soap, and start scrubbing the stain. But to your horror, the yellow stain suddenly turns a terrifying, deep red. Why on earth did washing it make the stain look so much worse? Okay, before we solve these cases, I have to introduce a massive plot twist into our investigation. Up until now, we've really only been using our eyes, but guess what? Some chemical clues are found with our noses. These are called olfactory indicators. It's a fancy term for unique substances whose actual smells change entirely when they're placed in an acidic or basic medium. To test this out, you take finely chopped onions, place them in a container with some cloth strips, and just leave them overnight so the cloth really absorbs that sharp onion smell. The next day, you put drops of tamarind water, which is highly acidic, on one strip. On another strip, you put a basic baking soda solution. When you check the odors again, you'll find the acidic tamarind water leaves the onion smell totally intact, but the basic baking soda destroys the onion scent completely. You are literally smelling the chemistry happening in real time. Cracking the cases, revealing the hidden science. All right, detectives, this is it. We've gathered our evidence, we've built our tools, we've studied the behavior of acids, bases, and indicators. It's time for the grand finale. Let's open up our casebook and unlock all of these unsolved mysteries once and for all.
Let's start with our very first hook, that baffling science fair mystery. How did a completely blank page suddenly reveal a welcome message? Well, it was a clever chemical trap. You see, the paper wasn't actually blank. The message was pre-written using a clear soap solution. When the volunteers sprayed the paper, they weren't spraying water at all. They were spraying a liquid turmeric solution. Since soap is basic, and we know turmeric turns red when it hits a base, bam, the hidden soap letters instantly turned bright red and became totally visible.
And honestly, that exact same science solves curious case number 3, the laundry disaster. Curry gets its beautiful yellow color from turmeric. So that curry stain, it is essentially a giant natural indicator right there on your shirt. When you apply soap to clean it, you are applying a basic substance directly onto the turmeric. As we now know, turmeric reacts to bases by turning red. So you didn't actually ruin the shirt, you just conducted a brilliant accidental chemistry experiment.
So what about Kirthi's secret birthday message from case number 1? She wrote it with orange juice. Now, orange juice, much like lemon or amla juice, is an acid. To help her grandmother read it, we simply need to provide an indicator that reacts to acids. If the grandmother wipes the paper with our homemade red rose extract, those acidic orange juice letters will react and turn a deep, highly visible red, revealing Kirthi's lovely message.
Finally, case number 2, the baffling hydrangeas. The secret here is that the hydrangea plant itself is just a massive, living, natural indicator. The flowers are simply responding to their environment. Because of this, gardeners can actually act as chemists. If their soil is too basic and they want blue flowers, they can treat the soil with organic matter to make it acidic. On the flip side, if they want pink flowers, they can add basic substances, like quicklime, to acidic soil. They are literally painting their garden using the pH scale.
And that, my friends, brings us to the end of our casebook. We've seen how remarkably simple things, a rose, a pinch of turmeric, a slice of onion, can reveal the hidden, totally invisible nature of the world around us. So, my fellow detectives, I leave you with this final thought. Armed with your brand new kitchen indicators, which household mystery are you going to investigate next? Thanks for tuning into this explainer, and happy sleuthing.